Welcome to day 3 of workout 4.1, and on day 3 we're going to do workout B and workout F. So workout B is back on this first sheet we looked at. We did workout A on day 1, workout B today. So let's have a little look at what sort of multiplication is going on here. It says we may need to work them out on another piece of paper. So we're thinking about maybe using our known facts again. So we can see we're multiplying by 6, 7 and 9 most of the time here. Those are the tables that we're working on particularly at the moment. So we're going to be maybe practicing our formal written methods for this, or we could be thinking about partitioning. So for example, if I'm doing 6 multiplied by 14, I know that that's the same as 14 multiplied by 6, yeah? Multiplication being commutative, I can swap it over. So I might think about partitioning my 14. 14 is 10 and 4. Well, 10 times 6 is 60. 4 times 6 is 24. So I could add those together to give me 84. So for some of these, it might be quicker and easier to do it in that way as a mental calculation rather than doing it as a formal written method. 4 6s are 24. So I've got 4 1s and 2 10s in my 24. 1 6 is 6. Add the 2 that I've got down here. 84. So either of those methods is fine. Maybe you could do it both ways, up to you, okay? So go and have a go at solving workout B as quickly as you can. Come back and we'll look at some answers, and then we'll have a look at workout F. Okay, so here's the answers to workout B. Check yours against mine, see how you got on. If you've got any mistakes, have a little look, see what went wrong, and see if you can work out the correct answer. So we've got one here looking at chocolate buttons and crisp hoopos. Okay, we've got some prices, so 60p and 70p. And you're going to be buying combinations of these so that you spend £12 exactly. All right. So we've got a bit of information here that's quite important as well. That Alec buys twice as many packets of crisp hoopos as chocolate buttons. Okay, so you think, well, what does that mean? Therefore, don't worry about the rest of the challenge for now. Let's just look at this bit to start with. Okay, so you might want to go and have a go on your own right now without any other help. Then come back if you need a hint, or stay and listen to a bit more now. So what do I know? I know that there's twice as many crisp hoopos as chocolate buttons. So if I had 1 packet of chocolate buttons, I'm going to have 2 packets of hoopos, yeah? So I might think about, you could think about a bar model, couldn't you? So you think, okay, so for 1 packet of chocolate buttons, that would be 60p. I'm going to have 2 packets of hoopos, which are 70p each. So one possible way of spending would be 60 plus 70 plus 70. Okay. Now, if I had 2 lots of chocolate buttons, then I'm going to have twice as many, so 4 lots of crisp hoopos. So you might want to think about maybe what that looked like as a list or a table. Or you could just do some trial and improvement. You could just try multiplying by some numbers by 60, some numbers by 70, and see how you can combine them to get £12. Once you've solved that, it then says, oh, what if he spent £7.50 and bought 3 times as many packets of chocolate buttons as crisp hoopos? Okay, so 3 times as many chocolate buttons as hoopos. So that's the other way around this time, isn't it? So if he had 1 packet of crisp hoopos, he's going to have 3 times as many 3 packets of chocolate buttons. So again, a bar model might help, or a table, thinking about how you might spend the money. For example, thinking about if this was my hoopos and this is my chocolate buttons. If he bought 1 packet of crisp hoopos, that would be 70p. He'd buy 3 times as many packets of chocolate buttons. Well, 3 lots of 60. I know that 3 6s are 18, so 3 60s will be 180p. So that's one possible combination of the money he could spend in this second problem. Okay, so again, maybe listing them might be a good way to try solving it. Go and have a go. So this puzzle at the bottom here is working on the same principles as this one, okay? So you've got different prices. You've got 80p and 90p now, and you've got different combinations. Okay, but the principles for solving it are the same as this top problem. So you should find this a bit more straightforward having solved this one. Off you go.